The data pump architecture, we have the operator who's going to call the SPDP command. When this command is called, the first thing that's created is what we call the control process. The control process is like the brain of the data pump job execution. So this control process will first instantiate what we call control table or master table. This is the table where this job will track and keep the execution status and all the parameters provided for this job. And also we're going to see later on the next slide more information we have on that table. After this table is created, the control process uses Oracle Advanced Querying to put all the tests that we need to execute for this data pump job in a line. So after this advanced querying is created, we have the worker process. So for an execution where we have no parallelism, we will have at least one control process and one worker process. When we have a multiple parallelism here, then we are going to have multiple worker process taking tests from this advanced querying. So the worker process takes the first test of this queue, get the data from the database, and write this data on the dump file. The control process will also write data on the control file from this control table. So the control process needs to update the dump files with the control table that's going to be kept on the dump file as well. Now let's see what we have inside this control table or master table. So this table is the table that usually we see inside the database as sys schema export 01 or 02 or 3. So these tables, again, are the tables that contain a specific data pump job execution. It has all the job info and parameters. It has the current status of that execution. You have also the object information, the index, and this is what enables the data pump job resumability, because this table, if you have an abort of your data pump process, this table will be kept there, and then the data pump job can resume checking on that table the steps that were already executed. So this control table is dropped only in the end of the completion of the job if the job was successful. If it has any failure, then the table is kept there for resumability. And again, that's sometimes when we see a schema in a database, we see a lot of those tables with 01, 02, 03 in the end. That's because of the previous executions of data pump export that failed by some reason. You can officially force to keep the table then even when the job ends with a successful execution, if you use this parameter, keep master equal to yes. This table can be created like any other table. So you can create your own queries. You can have your automations to check the execution status, the execution percentage, just creating this table. And this table is the first object imported when you run InPDP. So when you run InPDP, first the dump job will create this table on the tar database. Then it's gonna read this table to import the objects from the dump file. So again, how we keep that table, we use this keep master equal to yes parameter. And here we see that we have in red here, the sys schema export, sys export schema 01 table being created in the beginning. And in the end, we have the table was successfully loaded or unloaded, meaning the table is gonna be kept in the end of execution. We can also query this table, again, as I said, as any normal table in the database. And here we see some job information like the log file directory, the log file name, the client command that was executed, if you specified in compression, or if you restricted your job for a specific schema, you have all the information on that table.